Let us now discuss problem number 5. Compute the flexural strand of the T-beam shown below. Use F prime C, which is equal to 27 megapascal. Fy, which is equal to 350 megapascal. Assume rho max, which is equal to 0.0264. The concrete clear cover is 20 mm. So pag sinabi natin concrete clear cover, so from the face nung stirrups natin to the outermost fiber, that is 20 mm. So kung 20 mm tayo dito, sa taas din, that is 20 mm. And the clear layer distance between bars in tension, which is equal to 25 mm. So meron tayong clear layer distance. So since meron tayong dalawang rows ng 25 mm diameters dito sa beam natin, so yung distance between, so usually, yung distance between these two row is yung diameter nung bakal natin. So the distance between these two is yung 25 mm. So use NSCP 2015. So hahanapin daw natin yung flexural strength nung beam natin dito, which is denoted by M sub U. So ngayon, paano natin malalaman na T-beam yung illustration natin dito? So, since magkasama naman sa reinforcement yung slab natin at saka yung beam natin, so we can say na monolithic yung pagbuhos natin sa slab at saka sa beam. Therefore, T-beam yung kino-consider natin. So for this one, meron tayong bakal sa taas, which has a diameter of 22 mm na 3 peraso. So on the tension side naman, meron tayong 10 peraso na 25 mm na bakal. And yung stirrups naman natin, we have a 10 mm diameter bar nung stirrups natin. So sir, how we will going to analyze the T-beam kung doble siya? So you will just integrate yung mga natutunan natin sa T-beams plus dun sa doubling reinforced concrete beam na diniscuss natin sa mga previous modules natin. For this one, let us calculate for the value of your effective depth. So sir, paano yung effective depth natin dito? So from the tensile, dito sa tensile reinforcement natin, it will be located from the center of your reinforcement. So since parehas lang naman yung mga bars natin, tapos 2 rows lang sila, therefore, yung centroid ng mga bakal natin dito yan. Okay. So from the center, going to the outermost fiber ng beam natin on the compression side, that is the location of your effective depth. And how about naman yung D' natin? That is naman the distance from the center of your compression steel reinforcement to the outermost fiber in compression naman. So for the value of your D', ayun, gitna lang ng bakal natin. Same principle lang sa D. So gitna lang ng bakal natin hanggang sa outermost fiber ng beam natin. So first, let us calculate for the value of your D. Hanapin natin si D. So for this one, D is equal to, so yung total height ng beam natin, we have 390 plus 110 minus yung clear concrete cover natin na 20 mm minus yung diameter ng stirrups natin na 10 minus yung diameter ng isang row ng bakal natin na mayroong diameter na 25 minus yung kalahati ng 25 mm natin. So you will have a value of your D which is equal to 432.5 mm. Next naman, what is the value of your D'? Ito naman, so from the clear concrete cover natin na 20 plus yung diameter ng stirrups natin plus yung kalahati nung diameter natin dito sa compression steel bars natin. So you will have a value of D prime which is equal to 41 mm. So next naman, let us calculate for the value of your AS and for the value of your AS prime. So sa AS natin, meron tayong 10 piraso ng bakal na merong diameter na 25 mm. So you will have 1,562.5 mm squared. Yung AS prime naman, that is yung compression steel bars natin na meron tayong 3 piraso ng 22 mm diameter bars. So you will have a value of 363 pi. So of course, since meron tayo dito na T-beam, yung first procedure natin is T-beam siya, tapos meron siyang doubling. So yung first procedure natin, so eto kinuha muna natin yung mga values. So yung next procedure natin is check if real DRB muna. So paano po natin i-check yan? So we will just acquire the value of your actual, which is AS over BD. So yung AS natin dito, that will be 1,562.5 over the value of your B. So yung gagamitin nating B, eto yung width ng beam natin, which is equal to 300 multiplied by the effective depth of 432.5. So you will have a value of your actual which is equal to 0.0378. And yung raw actual natin, you will just compare that to the raw max. Since yung value ng raw max natin is only 0.0264, therefore raw actual is greater than raw max, therefore doubly reinforced beam. So after checking if your beam is a real DRB, next naman, we're going to check if our beam is a real T-beam. Sir, how we will going to check if that is real T-beam? So gagawin natin dito is we will going to assume that A is equals to the thickness of the flange, which is equal to 110 mm. And after that, since doubly reinforced beam tayo, we will going to assume that your compression steel bars will yield, wherein if that will yield, the value of your Fs prime will now equal to Fy. So same principle lang tayo dito. So kunin muna natin yung value ng tension natin. So yung tensile force natin, that is AS Fy. So the value of your AS is 1,562.5 multiplied by Fy, which is equal to 350. So you have a value of your tensile force, which is equal to 1,718.058 kilonewton. So eto na ngayon yung value ng tensile force natin. So yung goal natin dito is mapag-balance natin yung tension at saka yung compression natin. So for this one, meron tayong ibabalance na 1,700 na kilonewton. So let's now compute for the value of your C sub F. So paano ngayon kapag doubly reinforced yung C sub F natin? So parehas lang naman. So una is yung sa area ng compression natin plus yung sa compressive steel bars natin. So for this one, yung CF natin, that will be 0.85 F prime C plus yung area nung concrete nung flange natin. So that will become, so yung thickness ng flange natin multiplied by the base of the flange plus yung C2 natin, that will become AS prime multiplied by Fy. So, hanapin natin yung value ng C sub F natin. So, you will have 0.85. So, yung F prime C natin, that is 27 megapascal. The thickness of your flange, that is 110. And the base of your flange, that is equal to 600. Plus the value of your AS prime, which is equal to 363 pi multiplied by Fy, which is equal to 315. So the value of your CF is now equal to 1,913.839 kilonewton. So we will now compare yung value ng T natin and the value of your C sub F. So the goal is kailangan mapag-balance natin yung tensile force at saka yung compressive force natin. So sir, paano po natin ile-lessen ngayon? Kasi yung co-tension natin 1.7, yung compressive force that is 1.9 ngayon. So dito ngayon, yung mangyayari is i-adjust natin yung area nung nung compressive force natin. So meaning to say, since yung CF natin is greater than to the value of your T, therefore, not T-beam tayo. So, babawasan natin yung area nung konkreto natin para mag-equal siya or mabalance siya sa 1,700. So, not T-beam tayo. Therefore, wide rectangular beam tayo. So, kung wide rectangular beam tayo, yung analysis lang natin dito is the same as ng mga previous discussion natin. So, therefore, the value of your height of your compression block, that is less than to the thickness of your flange. So next, we will now solve for the value of your A, or the height of your compression block. So C is equals to T lang tayo dito. So assuming that we will going to begin with an assumption. Assume compression still will yield. So the value of your Fs prime, that is equal to Fy. So for this, unahin muna natin yung sa natin, konkreto, 0.85 F prime C. The value of your A multiplied by the base of your flange plus yung AS prime Fy. So eto, it is due to the compressive steel bars natin equals yung tension natin na AS Fy. So for this, substitute natin yung mga values natin. We have 0.85. Yung F prime C natin na 27 megapascal. Yung hinahanap natin na A, the value of your base of the flange na 600 plus yung AS prime natin na 363 pi multiplied by your Fy, which is equal to 350 equals yung AS natin, which is equal to 1,562.5 pi multiplied by Fy, which is equal to 350. So the value of your A is now equal to 95.782 mm. So, kung i-check natin, yung value ng A natin, that is less than to the value of your thickness of the flange, which is equal to 110 mm. So, hahanapin ngayon natin yung value ng C natin kasi nakuha na natin yung value ng A natin. And after natin makompute yung C, we're going to check if our assumption is correct or not. So, in computing for the value of your C, that is simply C is equals to A over beta. So, since yung natin, NSCP 2015, your limiting value is 28 megapascal. Tapos, yung actual F prime C natin, that is only 27 megapascal. So, we will just use 0.85 for the value of your beta. So, C is now equal to 112.685. So, after computing for the value of your C, we will now going to check if assumption is correct. So, what will happen for that? So, compute natin yung value ng Fs natin. So, we have 600 So yung D natin, that is equal to 432.5 minus the value ng C natin na 112.685 over yung C natin na 112.685. So the value of your F sub S, that is equal to 1,702.921 megapascal. So which is greater than Fy. Therefore, your tension still bar will yield. Next naman, let us calculate for the value of your Fs prime. So that is 600 multiplied by C minus yung D prime natin, which is equal to 41 mm over yung C natin. So you will have a value of your Fs prime, which is equal to 381.692 megapascal. So yung Fs prime natin, that is greater than the value of your Fy. So what is the value of your Fy? That is 350 megapascal. Therefore, compression still will yield. So after checking if your assumption is correct, since we proved that all of the assumptions that were made in our calculations are correct, so let us proceed to our next step. So let us now calculate for the value of your M sub U. So that is reduction factor multiplied by the nominal moment. So yung tanong ngayon, what will be the value of your reduction factor? Since your Fs, which is equal to 1,700, is greater than to 1,000 megapascal, therefore the value of your reduction factor, that is 0.90. So hanapin muna natin yung nominal moment natin. So for the nominal moment, so unahin muna natin yung sa compression natin, area natin, multiplied by yung moment arm natin na D minus A over 2, plus yung sa bakal natin, multiplied by the moment arm of D minus D prime. So in computing for your nominal moment, so you have C sub 1, so that is equal to 0.85 F prime C, A multiplied by the base of your flange, multiplied by yung moment arm natin, plus yung C sub 2 natin, which is yung compression steel bars natin. We have AS prime, so this is Fy na, multiplied by the moment arm of D minus D prime. So let us now calculate for the value of your nominal moment. So we have 0.85, yung F prime C natin, that is 27. So the value of your A is 95.782, and the value of your base of your flange, which is equal to 600, multiplied by the moment arm of 432.5 minus yung A over 2 natin, plus etong AS prime natin, yung sa bakal naman natin, we have a value of 363 pi multiplied by Fy na 350, multiplied by the moment arm of 432.5 minus 41. So you have a value of your nominal moment, which is equal to 663.531. So in computing for your MU, that is only 0.90, or your reduction factor multiplied by the nominal moment. So you have an ultimate moment capacity of 597.17 kilonewton meter. So this will now become the value of your ultimate moment capacity.